Imagine you have X-ray vision that lets you look inside an airplane engine without taking it apart. That's what a borescope inspection is like. It's a way to inspect the inside parts of an engine using a special tool called a borescope. This is extremely important for keeping planes safe and making sure everything runs smoothly. We'll use the CFM56 engine as an example, since it's found on many of today's airplanes. Keeping this engine in tip-top shape is crucial for safe flights. By using a borescope, mechanics can find small problems before they turn into big ones. It's like catching a tiny crack in your windshield before it spreads. There are two basic types of borescopes: rigid and flexible. Rigid borescopes are straight and give clear pictures. They're good for looking straight into an engine. Flexible borescopes, on the other hand, can bend and twist, making them great for exploring hard-to-reach spots inside an engine. Today, flexible borescopes are more common than rigid designs. Many modern borescopes are custom-made to work with specific engines. Once it has been determined that the engine is safe to inspect, the borescope is inserted into one of several ports designed for this purpose. Here are the port locations on the CFM56 engine. And for comparison, here are the ports on a PT6A engine. The borescope has a camera that sends pictures or videos to a screen so the mechanic can see what's happening inside in real time. If a problem is identified, such as a crack or wear and tear, the mechanic will take pictures and make notes. Most companies have a shared drive system that enables tracking and transparency. If the area of concern is small, it can be monitored for progression to reassess its condition in future checks. Borescope inspections are routinely performed during regularly scheduled checkups. They may also be performed when something unusual has occurred, such as flying through a severe storm or hitting birds. Another reason to perform a borescope inspection includes strange noises or vibrations coming from the engine. Fan blades and booster blades are checked for any cracks, chips, or signs of wear. Even seemingly small issues can lead to major problems. Small cracks can develop from normal wear, but need to be caught early before they spread. The leading edges of blades can erode over time due to sand, dust, and other particles. Foreign object damage, or FOD, includes damage from debris like rocks or birds striking the blades. Moisture and environmental conditions can cause blades to corrode, weakening their structure. In addition to repairing the damage foreign objects may cause, any remaining intruders need to be spotted and removed. After repairs, blades need to be inspected for any signs of trouble. They should also be rotated to verify smooth, uninhibited operation. When inspecting an engine with a borescope, you're not just looking for obvious problems. You're also measuring tiny gaps, lengths, and depths to make sure everything is exactly as it should be. Many borescopes have overlays or grids that can be used to measure objects directly on the screen. Modern borescopes come with built-in features for measurement, such as laser pointers and scaling functions to help gauge the size of any defects or parts accurately. Borescopes allow for engines to be inspected without the need for disassembly. This makes them cost-effective tools for improving engine maintenance. Problems can be detected early, decreasing downtime and increasing engine reliability and safety.